Here's one which is just a little bit different, and then it's got x's in it. The previous ones, if you have looked back at them, were all just numbers, or potentially an n for the power of n. But here we've got x's and something that's incrementing. So the power is going to be going with the n, and we've got to deal with the x's. So in this case, the nth term is going to be x to the power of n divided by something times n. So 5 to the power of n. So this is our first term, our second term, so x to the power of 1, 5 to the power of 1, and this thing is 1 more than n, so it's n plus 1. Okay, and then to find the n plus 1th term, just wherever you see an n, you increase it by 1. So n plus 1 becomes n plus 2, 5 to the power of n plus 1. Okay, and then we form our ratio. un plus 1 divided by, so un is un plus 1, is this one over here, times the inverse of un, so it's divided by un, so it's times the inverse, so we get 5 to the power of n on n plus 1 times xn. Okay, and then we're going to try and simplify this a little bit. That xn can go out with all of those x's except for 1, so there'll be 1 x left. And then likewise, all of those 5s can go with that 5, and there'll be 1 5 left. So on the bottom we're going to have 5 lots of n plus 2 times n plus 1. I've made a complete stuff up of that, so it's going to be time to fix it up. When I copied this to here, I got it wrong. That n plus 1 should have been on the top, so that n plus 1 should be on the top. So let me just write that again so you can actually see it. Okay, not to don't get put off by making a mistake. Find it and go back and fix it. Okay, so that's a reasonably nice format for our ratio, and now we're going to try and find the limit as n goes to infinity of the ratio. So it's the limit as n goes to infinity of x over 5 n plus 1 over n plus 2. Okay, and what I want to do here is just have a look at the usual routine. We can divide throughout by n, so we get the limit as n goes to infinity of x, and we're going to divide each term by n, so that'll be 1 plus 1 over n over 5, 1 plus 1 over n. And then, as usually happens when we do this, that goes to 0 and that goes to 0, and we're just left with x over 5. Okay, so the limit of our ratio is x over 5. Noticing that this is a modulus, if you have a look back at the formula, you'll find that we're interested in the modulus of the terms. It's to do with whether the series is a series of positive numbers. So if this is positive or negative, we're okay. So for convergence, the limit as n goes to infinity of our sequence has to be less than 1. And the modulus thing effectively means that the modulus of this has to be between -1 and 1. So in this case we're looking for x minus 5 has to be less than 1. So make a bit of space here. So you want -1 to be less than x over 5 to be less than 1. If we multiply through by 5, we end up with -5 is less than x is less than 5 for convergence. Okay, so this will converge. If it's outside that range, it will diverge. So in general, it will, in this particular case, so convergence for x over 5 less than 1, divergence for x over 5 greater than 1, and inconclusive for modulus of x over 5 equals 1. Okay, so this situation is x equals 5 or negative 5. We don't know. The convergence one we've already done, so x has to be between negative 5 and 5, and the divergence ones are the other ones, so x is less than negative 5 or x is greater than 5. Okay, so if we put on a number line, we would have 0, 5, negative 5. So if x is in this region, it's convergent. If x is outside of that region, it's divergent. And if x is exactly equal to the dividing points, it's inconclusive. Oops, spelling difficulties there. This is what we do in maths, not English. It's inconclusive. So we talk about the radius of convergence. So the radius of convergence in this case is 5. Okay, so it's a little bit different than the previous examples in that when you look at this thing right at the top and you ask, does it converge or diverge? Well, the answer is it depends on what x is. If x is between negative 5 and 5, it converges. If x is equal to 5 or negative 5, it's inconclusive. And if x is smaller than negative 5 or bigger than 5, i.e. further away from 0 than 5, then it's divergent.